Welcome to Haxby Shed and part 7 of servicing this Harrison universal milling machine. Now if you saw part 6 last week and you look at this behind me, you probably think nothing's happened. Well, that's about right, because I've been waiting forever for the table motor bearings to arrive. I'm pleased to tell you they have just arrived this morning, and I'll just show you a clip of those at the end of this video. But in the meantime, I did do some test cuts on this machine on the vertical head just to see what it ran like, and also I spent a lot of time cleaning out the suds channels and rigging up a capacitor to run this 3-phase pump off single phase, only to find that the pump windings are burnt out. But I do go through the logic of it and explain how to calculate the size of the capacitor you need. So in the finish, I bought a cheap camping pump from eBay, and I'll fit that later, after I've done the table motor bearings. Anyway, I hope you find it useful. Now, after a few days of postal strikes, some goodies arrived this morning. Start with this 40-piece UNC UNF tap and die set. I might have said earlier, I've already got a UNF set which was combined with a Whitworth set I've got, but I couldn't buy UNC on its own, not without paying quite a bit of money. Also, none of these have split dies, but again, split dies are expensive. So this machine and my shaper and some of the stuff on the lathe is UNC, so sooner or later I had to buy one, didn't I? It was £27 delivered. So I bought this box for the static converter that I'm going to make for the suds pump. I did look for a metal box die cast, but none were the right size, and they were also too expensive. This was only £5 or £6 delivered. And if you want that in euros or US dollars, add about 25%. Then some of these micro switches, which I think I'll be needing to get the buttons sorted out on this machine so that the inverters work, are driven by the switches as I want. And then a couple of relays as well, which will be on the same sort of 24-volt control circuits for that reason. And finally, in this disclosure, a meter of 20mm internal diameter PVC tube, which should carry the coolant away from this table. So first I'm going to describe what came with the machine and then some of the bits as well. So in this box, I've got a Clarkson collet holder set with the spanner and everything, and 4 metric collets. And in addition, separately, I've got another Clarkson collet holder. Now most of what's here is with a 12mm drawbar. Now off eBay I managed to get 4 Imperial collets for £15 delivered. Then there's this shell mill holder. There's an ER32 holder. There's this, which looks a bit homemade to me, but it could be useful for holding a boring bar or something. And then a Morse Taper 2 holder. And what else? And this collet holder, which says on the side BE Limited. And initially I got 4 collets with it. And then we've got these two. This one is a Titanic Osborne, but that's got a 3/8 thread. And we've got this thing, and I've no idea what it is, so you might be able to tell me what that is. And that's got a 3/8 thread. But I can tell you one of these is Whitworth, and the other one I think is UNF. I don't have any collets for this Titanic Osborne. The only other thing that I got with the machine was the arbor. And I've got this 27mm Jones and Shipman arbor. Let's just check this is on shot. Yes, it's on shot. Now there's a few bushes missing, and they're quite difficult to get hold of. Anyway, you can see it. Oh, and I've got the support for the end of the arm as well. I haven't shown you that yet. Then, a few days later, after I got the machine, I got a message from the seller. And he said, oh, hang on a minute, I've looked in my cupboard, I've found a few more bits. So he gave me 4 more collets for this thing. He gave me the key for the arbor. Whoa. He gave me a holder for a boring head. Now I think that's a 7/8 20 TPI. That's how I measured it anyway. And then a washer, an end washer, and one spacer for the arbor. So that was good of him. He didn't need to do that, but said, well, you bought the machine, you get all the bits. So that's great. Now, in addition, I had a contact from Mark, somebody who I'd never heard of before, but he reached out to me and he said, look, I've got these two that I don't need anymore. That's ER32, and that's just what it looks like. And these, as far as I can tell, are brand new. So we met up, and he travelled quite some distance to be fairly close to me, and he wouldn't take any money for it, for them. So we managed to persuade him, my son was with me, we managed to persuade him to at least go to a cafe with us, and we bought him an egg sandwich and a cup of tea. Well, that was really good of him, wasn't it? Now, in the background, I've been buying up cutters at the Auto Jumble, and I managed to get a few, and I've been buying the Clarksons. So you can see what I've got here. I've got this roughing out cutter, which is what I'm going to try in a minute. And then this one, that's just a ball end mill. That, I don't know what that is. Maybe you know. Yeah, well, you could use it to put an edge on something, but it might have a specific purpose. I'm not aware of it though. Now, I've bought some milling cutters for this 27mm arbor. Now, you can buy 1-inch bore milling cutters as cheap as chips. You can buy a bucket load for, you know, £20 or something. But the ones to fit this are quite hard to find. Now, I may be mistaken, but it appears to me that the 27mm bore is for the metric cutters, because all I'm finding for a 1-inch arbor is imperial cutters. Now, my friend Tony reckons he's got a 1-inch arbor somewhere in his garage, but he's not been able to find it yet, I don't think, as of now. He's also got a pile of 1-inch cutters he wants to give me. So hopefully he'll find the arbor. Anyway, we'll set this up now to do a cut with that roughing cutter I've just put down somewhere and I can't find it. Right, I'm just trying to machine the end of this block of metal here. Nothing is trammed. It's just an experiment. Well, that was on a very slow table feed, but it seems to cut all right, doesn't it? And whilst I was cutting that, it was drawing about 7.7 amps, so there's no problem with the supply. I think the suds pump will be the next thing to tackle. Oh, and finally to say, if you saw me doing that bit of test milling, well, the table was travelling at 31mm per minute because those were the gears that I had in the box. Now, I did some speed and feed calculations last evening, and at that RPM, this table, we could probably run it at 225mm per minute. So maybe when I get the coolant working, you know, we'll have a go at that feed rate. Thanks to Ralphie at Ralphie Customs, I know that this plate is the end of the coolant cross gallery, and it has a self-cleaning rod on it. I was wondering how all those big curls of swarf got in there, because this drain at the top here has got a filter plate on it, but now I realise it comes out just like that. And there's one at the other side. I need a long flat plate to go in here really to scrape all this stuff up. I couldn't find anything in the kitchen to use. Nice collection of rubbish from this cross channel here. Anyway, now it's time to look at this. So I'm going to warm up this piece of PVC tube just a little bit, hopefully, so I can pull it off. It was about -6 last night, 20 Fahrenheit. That's quite cold for round here. But they reckon by Monday, it's Friday today, they reckon by Monday it'll be 13 centigrade. Oh, Celsius. I just can't kick the habit of saying centigrade. Anyway, I'll be out here in my shorts by then. Yeah, that was easy then. I warmed up the metal instead of the pipe. I didn't want to be taking this off right now, but I can't get to the screw on this end of the flexi cable. Anyway, you'll get a glimpse at the inverter. There's one just here. There's another one on the panel over here. Oh, I missed a screw. So it's a good quality industrial grade inverter, that one. IMO Jaguar Cub, but one generation earlier than the one I've got in the lathe. And just tucked in there is the inverter for the table drive, and that's an older generation again. That's a Eurotherm drive 582. Now the 582, because I've got the manual for it, came in various power capacities, and I don't know which capacity that has, but it's only an 8th horsepower motor anyway on that table. Now there's quite a lot of work to do in here, figuring out what on earth they've done. I can see that the main inverter here, the motor inverter, is off this switch, and then this inverter is off this switch here. This back rotary switch here, well, that was for the suds pump, and I'm guessing that's not connected on because you've got that which says on it suds. So, well, anyway, let's just get on with the suds at the moment. You know, why wouldn't you connect the reverser? It's the simplest thing to do with this inverter. You know, having looked at all that phooey in there, I'm just going to take this off from here. It's just easier. So we'll have to re-strap this. At least it's just got strappings on it, and we'll need to wire it up for low voltage. Usually on the back of the lid it shows you what the strappings are, but there's nothing there obviously. But we can see that this needs to run in a certain direction, clockwise from above. These nuts on here are 3BA. Well, that's a good sign. It turns. We might be lucky then. Today's mission is to get this 3-phase suds pump working off single phase. And if you don't mind, I'll just explain what I'm doing. Some people are going to know all this, but some people might not. Let's start with the difference between 3-phase and single phase. I'll do this really quickly. This is what comes out of your power station. 3 transmission lines. Each waveform looks the same, but each one is shifted by 120 degrees to the other. And between any 2 phases, RMS, we've got 415 volts here in the UK. And between any single phase and 0, we've got RMS 240 volts. We don't normally have this to our homes. Here, we get this. Now, when a 3-phase motor is configured for high voltage, between any 2 phases, you've got 2 of these windings in series, and this is called Y. But when you need to configure it for low voltage, which is 240 here, then each phase is only across 1 winding like that. And that's why we need to adjust the strappings on this thing, on this motor, to change it from this to this. So here we have our motor connected to 3 phases, and this by its nature creates a rotating magnetic field, and the rotor will then always spin the same way. If it's spinning the wrong way, you simply reverse any 2 phases. But when we come to powering the motor from a single phase, which way is it going to start? So this bit of circuitry over here performs the same function as the centrifugal switch on a single phase motor, but the 3-phase motor won't have that switch in it because it wasn't designed to operate that way. So basically you have a relay here which is connecting this starter capacitor in circuit to get this thing going in the right direction, and then this relay drops out and this capacitor is then out of circuit. Just like that and nothing else, you've got the problem that you're only running the motor off this single phase here, this single winding. So you can get more from it by putting in a run capacitor which is permanently connected, and by the magic of capacitors it's going to give you a phase shift across here, and so you can get something out of these two coils as well, these two windings, and not just this one here. But you have to decide or calculate, let's say, what is the value of that run capacitor. The start capacitor is normally about 4 times the run capacitor. Now this is what you'd see in a good static converter, and in fact I bought a box and I bought a relay because I was going to build one of these, but friends on YouTube have commented, you don't need to do that, it's too complex for a little motor, it's not necessary. What you can do is just have this run capacitor, and in this configuration it's called a Steinmetz connection, and there's a way of working out what that capacitor should be. So here's the formula, and that comes out at 2.24 microfarads, which works out at about 48 microfarads per horsepower. Because this is a relatively modern motor, to change the configuration from star to delta, or Y to delta, all we have to do is take these off and drop them off on this way, like that, look. And then the supply just comes on here. Well, that's now wired up. I've chosen this capacitor, which is 3 microfarads for 40 volts AC. Now what I would say is, if you're like me and you've got an old tin full of capacitors, check the voltage on them, because I've got some big ones but they're only 100 volts DC. Now I don't know which way this is going to want to start. It's buzzing. Right, I've added a 4 onto the 3. Capacitors in parallel add. So that's 7 microfarads. See if that'll go. Just more buzzing actually. It hasn't changed the outcome. It does buzz a bit more, but it ain't running. So I'm going to have to go back to first principles, I think, and just check these windings out. Well, it's not looking too good, folks. So across this winding here, I've got 180 ohms. That looks all right. But one end of it is on A1, the other one's on C1, which is kind of not what I'd expect. I'd expect that A1, A2. Anyway, I'm not getting anything across either of these. So it looks like these two are open circuit. So I'm going to have to take this motor casing off and see what's going on inside. If I'm lucky, there'll just be a broken wire somewhere, or a couple of broken wires. Well, unfortunately for this pump, it's the end. Now, I said I'd got open circuit between at least a couple of the coils. I had 180 ohms between these two, but I'm not even sure they're on the same coil. So I just thought I'd take it apart and see what I could find. Now, below this bearing there's an oil seal, and that oil seal must have failed, because look at all the gunge on here. And then when I look at the windings, look, they're all black and covered in oil. So I think that's what's done for it. Just look at the black on that rotor. So the lesson's obvious. I should have checked those windings before I started doing anything. But never mind, onwards and upwards. Now we know that this is burnt out. I actually took the windings out to see if I could find anything, but it was a complete waste of time, of course. I needed to find another pump, and Samuel Fielder put me onto this one. It's a camping pump. I bought it off eBay. 600 litres per minute, it says. He reckons there's too much comes out of this. It floods everywhere. We'll see what happens. I've taken a bit of this, just plastering corner edging for the mesh, and I'll put something like that on there just to act as a sort of basic filter, and then we'll try it out. I've got a bucket down here and we'll see how well it works. This is a 2-foot long plant tray, and my idea is to put this into the base of the mill. I don't want to flood the entire base of the mill with coolant. I think if I just cut about 10 mil off each end, it's going to fit. Here goes. I think that's going to do plenty, don't you? I think the problem is how to make it less. I don't know how much this 3-phase suds pump would have cost back in the day, but I can tell you that this pump was £7.99 off eBay. I ordered it on a Sunday night and it arrived by parcel courier on a Tuesday morning. Now how do you do that for £7.99? But I can tell you what else has arrived. 1 seal and 2 bearings for my table motor. Now I got a dispatch notice for these on the 20th of December and they arrived on the 5th of January by our National Postal Service, Royal Mail. Now I don't like to make political or other comments because they age very quickly, but looking at the facts of these two experiences, you know, I think it says a lot, doesn't it? Unfortunately.